Hi, this is Bushonomics here. How you doing today? Okay, so a question that I've been researching recently has been whether Noah's flood is actually possible. And by possible, here's what I mean. Is there actually enough water on the planet to cover the planet entirely? I was unable to find a suitable all-in-one sort of answer to this question online, but I was able to find all the necessary data to make a mathematically sound estimation, and that's what I intend to do in this video. Now, in order to answer this question scientifically, we must begin by learning a few things about the Earth's total water supply in terms of its cubic volume. We must use our basic understanding of physics and geometry to measure the additional volume needed to cover the surface of the Earth, and of course we must do some math to ensure that our research can withstand scrutiny. First basic question: how much total water is on the Earth? This includes liquid water, ice, and water vapor. We want to know everything. Every cubic inch, centimeter, foot, meter, mile, etc. For this information, I went over to the U.S. Geological Survey, where I found a few very helpful articles on the topic. According to the USGS, the total quantity of water in, on, and surrounding the planet in the form of water, ice, and water vapor is 1.338 billion cubic kilometers. This includes water in our oceans, freshwater lakes and rivers, aquifers, dams, everything. It includes ice in the form of glaciers, polar ice caps, and other formations, and it includes the water in the atmosphere in the form of clouds, general humidity, and so forth. Next question: how do we calculate the volume of water needed to cover the surface of the Earth? I must note at this point that, while I am addressing the biblical account of Noah's flood, I am taking my calculations only to the tip of the highest point on Earth. I am not concerned about the extra cubics of water which made the flood quote-unquote extra thorough. As we'll see shortly, an extra 15 to 20 feet or so worldwide would only make things worse for the literalists out there anyway. So back to our question. For illustration purposes, let's assume that the Earth is a perfectly flat sphere. No mountains, hills, valleys, depressions. We'll further assume that it has no satellite and therefore has no tidal cycle. We'll assume that its orbit is perfectly circular as well, to avoid any complications due to the sun's gravity, however minor. And lastly, we'll assume that it doesn't rotate about its axis. This last point is important, as the Earth's rotation actually causes its circumference to be slightly larger equatorially than through the poles. Now, let us put one mountain on our arbitrarily perfect Earth, and let us call this peak Flood Mountain, appropriately enough. Flood Mountain is quite high, of course. In this illustration I made it exaggeratedly so in order to illustrate my process. You can see that in order to cover Mount Flood with water, or at least put enough water on our perfect Earth that Mount Flood would essentially be underwater, we must add volume to our perfect Earth in the form of water, such that we have expanded the volume of our perfect Earth so that its radius includes the very, very tippy top of Mount Flood. In short, we must fill that outer zone with water. Rather than calling it added volume, it would be more accurate to say that we are moving existing volumes of water from somewhere in our hydrosphere in order to fulfill the biblical requirement that all the Earth be covered in water, just so we're clear. This brings us to our next question. How much water would it take to fill that outer zone? Please remember that for illustration purposes, I drew the outer zone way too big proportionally so that it was obvious where I was going. However, I think you can see what the basic calculations must involve. We must begin by determining the cubic volume of that outer zone, henceforth called the flood zone. Using our arbitrarily perfect Earth, this would be a simple process of mathematics. You would calculate the volume of the flood zone by subtracting the volume of the Earth from the volume of the sphere described by the tippy top of Flood Mountain. The volume of a sphere is calculated by multiplying the cube of its radius by 4/3 and by pi. So to take a basic example using my little drawing here, if the radius of our perfect Earth was 1,000 meters, and the height of Mount Flood was 100 meters, the equation for the volume of our flood zone would look like this. I could have done this presentation in this overly simplified manner and just been done with it. However, I wanted to challenge myself and take the accuracy up a few clicks in an effort to avoid an onslaught of literalist, creationist goalpost moving. So what we're going to do is we're going to discard our previous assumptions about our arbitrarily perfect Earth, and we're going to move toward a much more accurate model. The Earth is not a perfectly flat sphere, as we know. It has hills, valleys, depressions, and so forth. The Earth does have a satellite whose gravity does affect Earth's tidal cycle. I'll be discussing that more in a minute or so. The Earth's orbit is not circular, it is elliptical in nature. For the record, this has such a small effect on Earth's sea level that it doesn't make much difference anyway. Why do I keep mentioning sea level, you ask? I will come up to that very, very shortly. And the last assumption we're going to discard is the most important one. The Earth most certainly does rotate on its axis. This is one of the reasons why we can survive on this planet. And it is also the primary reason why our simple sphere minus a sphere calculation isn't good enough for the project that I'm undertaking here. So now we are dealing with the real world, more or less literally. The fundamental question is as follows. Is the volume of our flood zone greater than, roughly equal to, or less than the volume of water present on the earth? If the flood zone is greater, then a literal reading of the biblical flood account is impossible. If the flood zone is roughly equal to, or to any degree less than, the volume of water on the earth, then indeed the Bible is inerrant on this point. Calculating the volume of the earth is actually slightly more complicated than merely calculating the volume of a sphere. Due to its axial rotation, the earth is just a bit fatter at the equator than it is through its poles. It is an oblate spheroid. Thus, we must use a different equation to calculate its volume, expressed here. This equation takes into account the fact that an oblate spheroid has more than one defined diameter. Using the principles of geodetic science, we can determine with amazing accuracy the actual dimensions of the Earth. It is this branch of the earth sciences that is used in the worldwide GPS system, for example. Using the numbers geodetics provides us, we can now return to our previous simple sphere formula, revise it so that we are using the oblate spheroid formula, produce a more accurate result, and answer the question of this video. We will begin by replacing Flood Mountain with Mount Everest. Mount Everest is the highest point of Earth above sea level if we aren't being too picky about the fact that, again due to the Earth's axial rotation causing it to be slightly fatter at the equator, the highest point would actually be Mount Chimborazo in Ecuador, as its peak is closer to the equator and therefore slightly further from the center of the Earth than Everest's peak. Terrain altitudes, as you may or may not know, are measured from sea level. Sea level, simply put, is the average of high and low tides worldwide, which in turn are caused by the concurrent gravitational effects between the Earth and our Moon. Although you could argue that this wouldn't affect the actual volume of our flood zone, sea level most certainly affects what we refer to as the altitude of Mount Everest. Since the peak of Mount Everest defines the outer limit of our flood zone, I think it is important that we use the most widely accepted measurement of its altitude. The most accurate and widely accepted recent measurement of Mount Everest puts the rock peak itself at an altitude of 29,017 feet, or 8,844.43 meters. Geodetics tells us that the Earth's equatorial radius is 6,378.137 kilometers, and that its polar radius is 6,356.752 kilometers. Here again is our formula, shown with geodetically accurate numbers and using the oblate spheroid formula rather than that of a simple sphere. Next, we simply add the height in kilometers of Mount Everest, 8.84443, to our geodetic figures, turn the mathematical crank, subtract the Earth's volume from the tippy top of Mount Everest volume, and we learn that the total cubic volume, expressed in cubic kilometers, needed to fill our more accurate geodetically based flood zone is 4.517 billion cubic kilometers. Just as a reminder, remember where my research began. USGS says that the Earth only has 1.338 billion cubic kilometers of water in its entire hydrosphere. Numbers do not lie, and here is the truth they are telling us very, very loudly. It is not mathematically possible to read the biblical flood account literally. There simply isn't enough water on the planet to cover its entire surface, let alone to a depth of 15 to 20 feet. And it's not like we're coming up just a bit short either. Intuition tells us that the Earth would need approximately 3.3 times its current volume of water in order to fill our Everest flood zone. Of course, intuition, like common sense, can frequently be wrong. Remember again that the flood zone represents the water needed to effectively raise the sea level from its current level to the height of the highest point on the planet. In other words, we would need 4.51 billion cubic kilometers plus the Earth's current water supply of 1.338 billion cubic kilometers. So in order for us to read the biblical account literally, the volume of water on this planet would actually have to be well in excess of 5 billion cubic kilometers. Furthermore, it would have to have somewhere to store those extra 4.51 billion cubic kilometers after the waters receded at the end of the flood. This begs the question of, where did the flood waters recede to? In conclusion, I believe that people should be free to believe what they want. I believe that faith is a personal thing to each individual, whether you have or practice some variety of it or not. But if you're going to say that the Bible is inerrant, if you're going to say that the Bible is absolutely true, and that it must be taken literally word for word, and then you're going to butcher science in order to force your conclusions to fit your assumptions, please don't be surprised that you never get taken seriously. Thank you for your time. Thanks for watching. Feel free to rate, comment, subscribe as you see fit. My videos and my channel are open to everyone. Take care of yourselves.